All right, y'all. So this is going to be kind of a lengthy video, but I was going to try to walk through the entire review again. So if you were in class today and you got through several of these, then you can kind of just fast forward to where you need to get to and so forth. But just bear with me. I'm also hoping that we have minimal amount of interruptions while I try to do this video here at school. Okay. All right, so question number 1, the derivative of the function f is given by f prime of x equals 2 minus 2x sine of x squared. How many points of inflection does the graph of f have on the open interval -2 to 2? Okay, so a couple of ways we could do this. The first thing you could do right here, you could look for the extrema of this graph. Okay, so good thing is sitting over here, I don't have as bad of a glare, so hopefully that'll help us a little bit. All right, so if I just type this into y equals, okay, so 2 minus 2 x sine x squared. Make sure I am in radians, which I am not. Okay, and I'm going to change my window because we do only care about from -2 to 2. So I'm going to make my window from -2 to 2. We'll keep everything there for now. Okay, so -2 to 2, you can see right there that there is an extrema here and here. So our answer is in fact 2. Okay, that is one way you could do it. You could have also done it where we take the derivative. Okay, and if I take the derivative here, so that means f double prime of x would be -2 sine x squared plus 2x cosine x squared times -2x. And just so you understand, I did just make that plus a negative there. So that way, otherwise I would have to multiply the whole thing by that negative. So I just made that plus a negative and made that to a negative there to help with my signs on that. Okay. And then simplify that out a little bit. Okay, so we could do that, and then if we did that, we would still go here. Okay, I'm going to turn this one off now. Just keep this one on and graph. And now we're looking for sign changes. So you would see it changes signs here and here. So you're looking for sign changes on this one, okay? But for the original one, it would have been the extrema, okay? So same thing either way, sign changes or the extrema, you're going to end up with 2 for that one, okay? All right, number 2. A right circular cylinder is such that the sum of the height and the circumference around the base is 50 centimeters. What is the radius that produces a maximum volume? So again, important right there, maximum volume is what we're looking for. Okay, so it's the sum of the height plus the circumference, so 2 pi r is equal to 50 here for us. Okay, we're talking about the volume. So we're going to use V equals pi r squared h. So I'm going to solve this right here for h. So h is going to equal 50 minus 2 pi r. Sorry. Okay, so that's going to be pi r squared times 50 minus 2 pi r. Okay, so if we work that out, that's going to be 50 pi r squared minus 100 . Lord have mercy. No, it's not. Oh, my bad. Got ahead of myself. My bad, y'all. All right, it's going to be 50 pi r squared minus 2 pi squared r squared, r cubed. Okay, and then ultimately we're going to take the derivative of that. Give me a second, I'll go fill that back in. So distribute, so 50 pi r squared minus, and then that's going to be 2 pi squared r cubed. So then the derivative there would be 2 times 50 is 100 pi r minus, bring that down, so that's going to be 6 pi squared and then r squared, and we want to know when that is equal to 0. Okay, so I factored out a 2 pi r from there, which left me with 50 minus 3 pi r. In 1 second, y'all. All right, so back at it. My bad, y'all. All right. Okay, so when I did this from here, we want that equal to 0. So obviously this one right here is just going to be 0. And if I work this one out, we're going to get 50 divided by 3 pi. So that is going to be our r. And now, calculator active, okay? So calculator active, I'm going to take a second just to show you that's the math. All right, so we talked about it in class. You had to do the derivative, right? So there were a couple people in class that did it this way. All right, so they put, like right here, even just this one, the first one, pi r squared. So we're going to use x times 50 minus 2 pi x. Okay, that's on the first one. So then I want the derivative of that. Okay, so if I took the derivative of that, I'm going to hit math 8. So we're going to dy dx. That's ny1, so alpha, trace, enter. And we just want to put x equals x here, okay? I don't need to graph this one, so I'm going to turn that off. I'm going to hit enter and turn that off. Okay, so I'm going to hit graph here. And I got to change my window. Okay, so then here, right here, if you notice, because this is what we were talking about in class, so this is the same thing. If you were to find that 0 right there, it's going to be 5.3052 centimeters, and there's nothing that tells me it has to be either one, so we did talk about that in class as well. All right. Okay, question number 3. A particle moves along a straight path with a velocity given by v of t equals 7t minus 1.01 to the negative t squared at time t is greater than 0. All right, what is the acceleration of the particle at t equals 3? Well, acceleration is equal to the derivative of velocity. So the acceleration at 3 is equal to the derivative of velocity at 3. So we just went to our calculator again. Okay. All right, so our initial is 3x plus 4.1 sine x. Okay, so that was our initial. And we're only going from, oh Lord, wrong problem. okay? Or, so that's in y1, right? And then we want to know for the time equals 3. So I'm going to second quit. I'm going to math 8. I want dy dx of y1 at x equals 3. And we're going to get 7.0546. They didn't give us any units in here, so we are good to go. Okay, all right, number 4. A particle's position is given by the function p of t equals 3t plus 4.1 sine t. For t is greater than or equal to 0, find the total distance that the particle travels on the interval 3 to 5. Okay, so one way, we know that total distance particle travels. All right, so the position is given here, so we're going to find the velocity. So v of t is going to equal to p prime of t, which in this situation is going to be 3 plus 4.1 cosine t. And we want to know where that is equal to 0. Okay, and whenever I graph this initially, you'll just see a whole bunch of stuff on there. I'm going to change my window because it tells me that we're between 3 and 5, so I'm going to make my window from 3 to 5. Okay, and then you'll see that 0, so we're going to second trace. We want to find the 0 there, on the left, on the right, and in the middle. So 3.8915 or 16. Okay, just depending on around 8915, 8916. Okay, it will slightly change depending on which one you used. I did use 8915. Okay, so for our total, so now this is a critical point. So now for our total distance, remember we're going to start at this one. So absolute value of p of 3 minus p of 3.8915 plus p of 3.8915 minus p of 5. So we've got the start and end point, we've got the turnaround point. Okay, and if you add all that up, however you do that, whether you do that individually, all at one time, or whatnot, we should get 2.8869. Okay, might be a slight difference in your calculations if you used 1/6 here. I didn't, so I'm not exactly sure what that would be, but there might be one. Okay? All right, number 5. All right, so the function f is continuous and nonlinear. Okay, so continuous and nonlinear between -3 and 7, and f of -3 equals 5, f of 7 equals 5. There's no value of c between -3 and 7 for which f prime of c equals 0. Which of the following statements must be true? Okay, so let's talk about a couple things here. All right, we're continuous and nonlinear. Okay, so if I look here between -3 and 7, but it tells me -3 is 5, and it tells me 7 is 5. We're nonlinear, and there's no value right here, no value of c for which f prime of c equals 0. So that tells me that it's nonlinear, so it has to have some kind of extrema, but f prime is never equal to 0. Therefore, our derivative does not exist, which kind of to me tells me that we have a cusp. So something like this, okay? Because right there at that top, f prime of c would not be equal to 0. We're continuous, but we're not differentiable. Okay, so if that's the case, for some c on -3 to 7, f prime of c is less than -1. Well, this could have gone down, but it could go up like I have it. So letter A is not guaranteed. It's possible, but it's not guaranteed. All right, for B, -3 to 7, f prime of c is greater than -1. Well, again, it's possible, but there's nothing that guarantees that. All right, for C, some value of c, -3 to 7, f of c equals 0. Well, it could be. My graph again went up. We could have gone down and crossed over here, and then we would have a 0, but there's nothing that makes that guaranteed to happen. F prime of C, well, no, we know that's not true because F prime of C does not equal to 0. Right here, F prime of C says no value where F prime of C equals 0. Okay, so that's not true. So then yes, for some value of C, y'all, it literally said that right here. There's no value of C between -3 and 7 for which F prime of C equals 0. For some C on -3 to 7, F prime of C does not exist. There is some value. It just says that. Okay, so it is E. All right, number 6. Okay, so I'm going to start here by going ahead and graphing. Okay, so we've got sine t, so sine x over cosine 2x. All right, and we are just greater than 0, so I need to, okay, greater than 0, so I'm going to set my window. And now, if you look here at your numbers, t starts pi over 6 to 2 pi over 3. So I'm going to make my window from 0 to pi, because pi is slightly larger than 2 pi over 3, so that should cover everything we need. And we want to know where it is slowing down. So we want velocity and acceleration to have different signs. Okay, so you can keep your y whatever you want it to be. Let's graph it from here and see what happens. Okay, so here's my graph now. All right, so then I'm just going to evaluate what happens at each one of these points. So at pi on 6, so second calc the value of pi over 6. Okay, so that's right there. So we can tell that we are positive on the graph, and the graph is our velocity. So we know that our velocity is greater than 0. And if you look, we are increasing there. Okay, therefore our acceleration is also greater than 0. Okay, but if we are slowing down, remember, we want our velocity and acceleration to have different signs. Okay, all right, so let's look at t equals pi on 3. So second value, pi over 3. Okay, so right here, and we can zoom in to see that, but you can tell that our velocity is going to be less than 0, but we are increasing there. We're going up on that curve, so our acceleration is going to be greater than 0. Okay, let's try the last one. Second trace value of 2 pi divided by 3. All right, and then we will see here that our velocity is less than 0, but we are going down, so our acceleration is also less than 0. So the only one that has different signs is going to be number 2. All right, number 7, a new robotic dog called the iPup went on sale at 9 a.m. and sold out within 7 hours. The number of customers in line to purchase the iPup at that time, t, is modeled by a differentiable function. Okay, so we know we're differentiable for 0 to 7. Values of a of t are shown in the table below. For 0 or t between 0 and 7, what is the greatest number of intervals of times on which Rolle's theorem guarantees that a prime of t is equal to 0? So remember, for Rolle's, okay, we've got to be continuous and differentiable. Well, it's differentiable, therefore it is continuous. Okay, so we're good there. And then we've got to have our endpoints are the same. So if you notice, our endpoints are the same here and here. So literally that happens once. Okay, and we talked about in class, let's just say that this right here was 150. Okay, so it was from here to here, but that would not count because you cannot include an endpoint for that to happen. Okay, so it's only once. All right, numbers 8 through 11. All right, so just to put in reference, calculator active problems numbers 1 through 7 would be multiple choice. 8 through 11 is where our free response comes in. Okay, the position of a particle moving along the x-axis at time t is greater than 0 seconds is given by the function x of t equals 2e to the t minus 2t feet. Find the average velocity of the particle over the interval 1 to 5 and be sure to indicate correct units of measure. All right, so over the interval 1 to 5. All right, so we are going to do our formula. So look at the secant with 1 and 5 up here. So x of 1 minus x of 5 over 1 minus 5. Okay, and we will plug all that in. Again, you don't have to do this. I've got it written out by hand, but we could put it into our calculator. 2e to the t, or to the x for us, minus 2x. So then y1 of 1 minus y1 of 5 over 1 minus 5. Okay, so I just put that straight in, y1 of 1 minus y1 of 5 over 1 minus 5, and that does give me 70.8474, and that is feet per second. Okay, because we're trying to find velocity, so that's units per second. All right, number 9. In what direction is the particle moving, and what is the particle's velocity at t equals 4? Okay, well, our initial equation here is 2e to the t minus 2t, so we're going to find our velocity equation, which is the derivative of that, so it's going to be 2e to the t minus 2, and then we're just going to find v of 4. Okay, now again, you've already got that in y1. You could do okay, you could just do that. So you've already got it in y1, so you could do math 8 because we're calculator active. Derivative of y1 at x equals 4, and it's going to be 107.1963, which is what I got. And that is feet per second, because that's velocity. Okay, and then it says justify your answer. So at t equals 4, the particle is moving to the right because velocity is positive. And that was a value of 107.1963 feet per second. So there is our justification for that. Okay? All right. What is the acceleration of the particle when the velocity is 0? Show the analysis that leads to your answer and be sure to indicate correct units of measure. Okay, so this one did take a little bit of work for me. Oh, just kidding. The wrong problem again. Okay, so we're back to here, and we want to find the acceleration, right? So that's the second derivative. Okay, so the derivative of velocity, so a of t equals v prime of t, all right, which in this situation is going to be 2e to the t. The velocity is equal to 0, so we've got to calculate that. So the velocity equal to 0, so velocity is 2e to the t minus 2. We want that equal to 0. So rearrange that, e to the t equals 1, so t equals 0, because anytime the 0 power is going to be 1. So then we're just going to plug in 0 here. So v prime of 0 is going to be 2 times e to the 0. That turns to 1, so our answer here is 2 feet per second squared. Okay? All right, and then 11, is your speed increasing or decreasing at t equals 3.5 seconds? All right, well, our velocity at 3.5, that equaled 64.2309. And our acceleration at 3.5 equaled 66.2309. Okay, and I can calculate that if I needed to, going back and looking at my velocity equation was given to me right here. Okay, so I could just do v of 3.5 there. Okay, which is where I got the 64.2309. And then our acceleration is just 2e to the t, okay, which is 66 points. So I just calculated those using their respective formulas. Okay, and so since they are both positive, the speed is increasing at t equals 3.5 because v of 3.5 and a of 3.5 have the same sign. Now you could say because velocity and acceleration and so forth. You don't have to necessarily use v of 3.5 and a. You could say because velocity and acceleration have the same sign. Serves the same purpose, okay? All right, so that ends the calculator active portion of your review. Okay, so now we're going to move into the calculator inactive portion. All right, so this is the one I was talking about a minute ago. Okay, number 12. Now, a couple of ways you could do number 12. You could, in fact, go and distribute all that out, okay? But there's a reason I'm not going to do that. So when we're looking here, a particle starts at time t equals 0 and moves along a number line so that its position at time t is greater than or equal to 0 is given by this function. On which of the following intervals is the particle always moving to the left? Okay, so we want a negative velocity here. Okay, so if I want a negative velocity, okay, this is my particle equation, so I'm gonna take the derivative of this. Now again, I could work this out, but if I do that, I'm gonna end up with a t to the 4th, and we ultimately want this to find our zeros, and we're calculator inactive, so I want to keep this as factored as I possibly can. So for that reason, I am not going to distribute this out. I am going to do the product rule and the chain rule to take my derivative, okay? So for v of t, we're going to say product rule, power rule, okay? Power rule right here, so 3 times t minus 2 squared. Chain rule, so times 1. So the derivative of the first times the second plus the derivative of the second times the first. All right, and we are going to clean this up. So I'm going to take this 3 times this t minus 6, and that's going to give me 3t minus 18 times t minus 2 squared plus t minus 2 cubed. Okay, so that's where I'm at now. Okay, I'm going to recognize that I could factor out a t minus 2 squared from both of these. So if I factor out t minus 2 squared, I am left with 3t minus 18 plus another t minus 2. All right, so t minus 2 squared on the outside. Inside is going to give me 3t plus t is 4t. Minus 18 and minus 2 is minus 20. And we want where those are equal to 0. Well, this one is easy. It's 2. That's going to be 20 over 4, which is going to be 5. So now I can put these on my, okay, we're greater than 0, so I'm going to go to 0 here, and then we've got 2 and we've got 5. 2 is a double root. Okay, 5 is a single root. All right, so let's just pick 1. Okay, so if I pick 1 here, whatever I get in square, it's going to be positive. That's going to be negative, so that's going to make this negative. Even dots stay the same, odd dots change, so we're down, down, up. So they want to know where do we have a negative velocity to the left. Okay, so if this was not multiple choice, we would have a negative velocity from 0 to union to 5, right? Okay, but let's look, 0 to 5, we can't do it that way because of the 2. Remember, we have to actually separate that, okay, because at that point, it pauses. All right, so then that won't go all the way to 5. We know 2, 5 works, so we're good there. 5 to infinity, well, that was positive, so that's not a negative velocity. 0 to infinity, definitely not, never. Okay, so B is our best answer. Okay, but if it was for response again, you would have to include both of the intervals. All right, number 13, the graph of f prime. So this is very important. This is the graph of f prime of x. Okay, the graph of f prime, the derivative of a function is shown below. Which of the following statements is true about the function f of x? All right, f of x, or f is decreasing on 0, 2, and 4 to infinity. All right, well, if we look over here from 0 to 2, Okay, it looks like it's decreasing, but remember this is f prime. So in order for that to be true, this would need to be negative. All right, so that is not true. All right, f has a point of inflection at x equals 1 and x equals 3. So a point of inflection would be the extrema of the graph. So let's see, x equals 1 and x equals 3. Okay, but again, this is the graph of the derivative. So a point of inflection at 1 and 3, okay, would be extrema of this graph. So that is not the situation. And number 3, f is concave up on negative infinity. So negative infinity up to 0. So we are increasing. So we are concave up. Okay. So that one will work. Okay. All right, number 14. Okay, and we talked about this one a little bit in class as well. So I am going to stack these. So I'm going to put my acceleration under. And my acceleration just has 2, and we're negative and positive. Okay, so we are looking for on which interval of time are the speed and the particle increase, is the speed of the particle increasing. So remember, for it to be increasing, the signs are the same. Okay, so from 0 to 2. All right, so from 0 to 2, which would be in here, well, from 0 to 2, our acceleration is negative the whole time, but we've got a sign change here, so that would not work. Okay, so in other words, our acceleration is less than 0, but our velocity changes. Okay, from 1 to 3. So from 1 to 3, our acceleration changes. From 1 to 3, our acceleration changes, and our velocity is negative, less than 0. Looking for the same sign. That's not the same. All right, the third one, 0 to 1. Okay, well, our velocity here is greater than 0. And from 0 to 1, our acceleration is less than 0. So, not the same signs. 2 to 3. All right, well, 2 beyond, our acceleration is positive. Okay, and from 2 to 3, we're going to have that our velocity is going to be negative. Okay, not the same sign. Okay, so clearly by now we're on 5. So let's see, from 1 to 2. So from 1 to 2 here, our acceleration is less than 0. And from 1 to 2 here, our velocity is also, so there it is. Okay. All right, number 15. All right, the graph of velocity, v of t, in feet per second of a car traveling on a straight road. For t between 0 and 50 is shown below. On which of the following intervals is the acceleration of the car positive? Okay, so again, this is our velocity that's graphed. Okay, so acceleration of the car is positive. We want to know where is our velocity increasing. Okay, that's what we want to know. Where is our velocity? So from 0 to 10. So let's look and see. From 0 to 10. 0 to 10. All right, we are increasing there. Okay, that'll work. Okay, which of the following? So 35 to 45. So 35 is here to 45, so that's down this way. Okay, we are definitely not increasing there. And from 15 to 35. So from 15 to 35, okay, we are also, so that's from here to here, and we are increasing there as well. So our answer is 1 and 3. All right, 16. For what value c is the instantaneous rate of change for the function f of x equals 2 squared x equal to the average rate of change on the interval 4 to 9. Okay, so instantaneous equal to average. So that's where there's our SOT equal our SOS. So slope of the tangent equals slope of the secant. Okay, well, in order to do this, we need to calculate our derivative. So we're going to, this is the same thing, of course, as two times x to the 1/2 power, right? So then if we do f prime of x, that's going to give me, bring down the 2, so that goes away, bring down the 1/2, so that goes away, so that's going to be x to the negative 1/2 power, or 1 over the square root of x. Okay, so that is our derivative. So they said for what value of c, so we're going to plug in c, does the slope of the tangent equal the slope of the secant? So the slope of the tangent will be 1 over the square root of c equal the slope of the secant. So that's going to be f of 4 minus f of 9 over 4 minus 9. And then we're going to work that out from there. All right, so 1 over c, f of 4. So plug in 4, square root of 4 is 2, 2 times 2 is 4. All right, f of 9, square root of 9 is 3, 2 times 3 is 6, over negative 5. So that's going to give me 1 over the square root of c equals positive 2/5. Okay. You can square both sides at this point, so you would get 1 over c equals 4 over 25. And then we're going to solve here to get that c does equal, you can get 4c equals 25 or c equals 25 over 4. Okay. You could have also gone here and then squared after that. It's completely up to you what you get there. Okay. All right, number 17. A differentiable function f on the interval -2, x is between -2 and 7, is such that f prime of c equals 0, where c is between -2 and 7. All right, and that graph is, and if f of c is greater than f of 7 is greater than f of -2, then which of the following statements must be true? Okay, so for 17, the first thing I notice is that f prime of c is equal to 0. And that lets me think rolls. But then, right here, we've got f of c is greater than f of 7 is greater than f of -2. So that's going to make me think about our extreme value theorem. Okay? So let's see what we've got here. F of 7 is the absolute minimum value on -2 to 7. Okay, well, this is saying, if I was to write this the other way, okay, so this is going to go from max to min. If I wanted to go the other way around, I could go f of -2 is less than f of 7 is less than f of c. So my min, the absolute minimum value, is definitely not f of 7 because f of -2 is smaller than that. Okay, the absolute max value is f of c. Well, that works. Okay. Okay. Number 18, looking down here at this graph. Yeah, I'm trying to get, sorry. I'm going to move it, make it fit. All right. A particle moves along a straight path. The graph to the particle's position, x of t, at time t is shown. So this is our particle graph. Okay. Positions, particle's position graph. At time t is shown below, 0 to 6. The graph, it has horizontal tangents at x equals 1 and t equals 1 and t equals 5, and a point of inflection at t equals 2. For what values of t is the velocity of the particle decreasing? Okay, so remember, velocity is decreasing when the position is concave down. Okay, so we are concave down starting here. So a of t has to be less than 0, and x of t has to be concave down. So from here, and then it's going to go all the way over to 6. Okay. We're getting there, y'all. Last page, I think. Yeah, last page. Okay, and again, multiple choice on your test would be from the beginning of our calculus, so 12 up to 18, and then our free response are going to be 19, which is a chart problem. We love tables. Okay, so much easier with a table. All right, so let's look at 19. For problems 19 through 22, the table below represents the value of two differentiable functions, f and g, and their first derivatives. Use the table to answer the following questions. Number 19, is there a value of r on the interval -2, 1, such that g of r equals 0? Okay, so g of r is continuous because it is differentiable, okay, because it says they're differentiable right here, okay? So let's see what we've got. So g of r is continuous because it is differentiable. We are going to establish that, okay? So the IVT okay, so our IVT does guarantee a value of r on -2, 1 because, all right, so let's look at our values here. -2, 1. So g of -2 is 4, okay? I'm going to just write that up here. So g of -2 is 4. And then g of 1 is -3. Okay? So you can say that there's a couple ways we can write this, because g of -2 is greater than g of r, which is greater than g of 1. We could have flipped that around and said g of 1 is less than g of r is less than g of -2. But anyway, r is going to be between, which the value there is 0, right? G of r is equal to 0, because you're going to have to go from 4 to -3. You're going to go through 0, and vice versa. All right, hang on one second, y'all. Get somebody at my door. All right. Sorry about that. Okay, so, all right, number 20. All right, approximate the value of f double prime of 0.5. Okay, so when we're doing this, what does that value say about the graph? All right, so we're thinking of approximate, we're thinking slope of the secant. Okay, so for 0.5, we're going to go between 0 and 1. So we're going to do f prime of 0 minus f prime of 1 over 0 minus 1. All right, so f prime of 0, so f prime of 0 is going to be 4, minus f prime of 1 is going to be 1 over 0 minus 1, so that's going to be 3 over -1, which is going to give me -3. And then what does that say about the graph of f when x is equal to 0.5? Okay, so because f double prime, we can say that f of x is concave up at x equals 0.5 because f double prime of 0.5 is less than 0. Lord. Concave down. Concave down. Okay, so just a reminder, I had to get up real quick and grab my little cheat card. Okay, so whenever we found out that this was, so this is less than, right? Okay, so there we go. We can say because it is less than, right? Then we are concave down. Okay, all right, number 21. All right, h of x equals g of x squared plus f of x. What is the equation of the tangent line? So the pot and the sot. Equation of the tangent line, we're thinking pot and sot here of the graph of h at x equals -1. So let's see what we've got. So for our pot, we're going to do h of -1, which equals g of -1 squared plus f of -1. All right, so g of -1 is 2 plus f of -1 is 2. So that gives me 4 plus 2 is 6, making my ordered pair -1, 6 for my pot. Okay? For our sot, we're going to do h prime. All right, so bring that down. So 2 times g of x times, so bring that down, and then the inside of that would be g prime of x plus f prime of x. And we're going to do that for -1. So 2 times g of -1 times g prime of -1 plus f of prime of -1. All right, so let's evaluate. So g of -1, go up here, g of -1 is 2. So that's going to give me 2 times 2. G prime of -1 is going to give me 1. So 2 times 2 times 1 plus f prime of -1 is going to give me -2. All right, got all that. So 2 times 2 is 4. 4 plus -2, or 4 minus 2, is going to give me 2 for my sot. So then my equation is going to be y minus 6 equals 2x plus 1. All right, last problem. All right, is there guaranteed to exist a value on C on -1, 1 such that h prime of C equals 0, and give a reason for our answer? All right, well, let's see what we've got. We know, let's find h prime. All right, so let's see. We've got h prime of -1, which we found to be, h prime of -1 we found up here to be 6, right? And then h prime of 1, so h prime of 1 will be g of, we have calculated that yet. All right, well, let's see what we got. So h prime of 1 would be 2 times g of 1. So g of 1 is going to be -3. So 2 times -3 is -6. So g prime of 1 is going to be -5. So let's see. Let's work that out. So that's g of 1 squared plus, that's because these aren't primes, they're just h's. That's right. H of 1, not H prime of 1 is 6. My bad. And then now H of 1. So we're going to go back up to here. So G of 1 squared plus F of 1. So G of 1, if I look up here, G of 1 is going to be negative 3. If we square that, that's going to give me 9. And then F of 1 is going to give me negative 3. So 9 minus 3 is, okay, so H of negative 1 is 6, and H of 1 is 6. So now my two are the same. Therefore, we can say that Rolle's theorem guarantees a value of C on that interval, negative 1, 1, such that H prime of C equals 0, because we know that H of X is continuous, differentiable, and H of negative 1 equals H of 1. And there you have it. All right, so make sure you study again. This is the most accurate thing you can study for your test tomorrow, which again is why I wanted to make sure I made the video on that for you today. All right, study hard, and we will see you all tomorrow.